All right, we're in section 8.5 where we are going to use the properties of trapezoids and kites. So if you look at the shape to my right, it's a trapezoid. Okay, so looking at some of the characteristics of a trapezoid, one of the things that we know is a trapezoid is a quadrilateral, which is a four-sided figure. Specifically, what makes a trapezoid is it has exactly one pair of parallel sides. And it looks like it's these two sides here. So put the little parallel sign to acknowledge that. The pieces of a trapezoid are as followed. The two parallel sides are called the bases. So it's like base 1 and base 2. And then the two non-parallel sides, those are called the legs. So it's like leg 1 and leg 2. Okay. If we go into other types of specific trapezoids, one of which is here, we have an isosceles trapezoid. So has the same characteristics as the top one. This and this are parallel, so these two line segments are parallel. But when you have an isosceles trapezoid, kind of like an isosceles triangle, you have two equal sides. So, and it's usually represented, it's going to be represented by the two leg sides of our trapezoid. Okay. But when you look at an isosceles trapezoid, other characteristics come into play because those two sides are equal. When those two sides are equal, we can also say that the base angles here and here are going to be equal. The base angles here and here are also going to be equal. And we can say that the diagonals, so the distance from here to here is going to be the same as the distance from here to here, um, going across the interior of that isosceles trapezoid. Okay. Another thing that we have when it comes to being able to figure out different formulas, we have what is called a mid-segment theorem for a trapezoid. So if we were to take a line segment and cut our two legs in half, so M and N are the midpoints of A, D, and B, C respectively, and you made a line segment there. In this case, we have that red line segment. We can figure out the distance of this mid-segment value by taking half of the sum of the two bases. So this is the two sets, the two pairs of, or the one pair of parallel lines in this trapezoid. So this is like base 1 and this is base 2. Add them together and then you divide it by 2 or multiply it by 1/2. Okay. The last thing that we're going to look at is look at a kite. Kites have a different type of characteristic. There are no parallel sides in a kite. The only difference is we are going to have um, consecutive sides to be congruent. So this side and this side are going to be considered congruent. They're going to be the same. And these two side lengths are also going to be congruent. Um, Another characteristic of a kite is the two diagonals where they meet. They are going to meet at a 90-degree angle. And the last characteristic of a kite is the two vertices that don't share the congruent side. So it would be like this vertice here and this vertice here. Looking at those two interior angles, they will also be congruent. All right. So let me be clear. Only these two angles are going to be congruent. All right. This angle here and this angle here will not be the same. Okay. So looking at our first example in the notes here, we have a series of ordered pairs, and they want to find out. It says we got points A, B, C, D are vertices of quadrilateral. They want you to determine whether A, B, C, D is a trapezoid. Okay, so what we have to figure out is if one pair of lines are parallel. So we have to figure that out. So you can use some graph paper if you want. I'm probably going to do that. So let's find some graph paper here. All right, so I got this. So looking at it, I got 10, 3, and 14, 4, 22, and 12, 0. So 10, 3, 14, 4, 22, and 12, 0. Okay, so for this, since they're all in tens, I'm going to go 2 units. So 10, 3, I got 2, 4, 6, 8, 10. 3 is right about there. So that's A. 14, 4, 2, 4, 6, 8, 10, 12, 14. And so that's B. C is I got 20 and 2. So that's C right there. And then I got 12, 0. 2, 4, 6, 8, 10, 12, 0. And I got that. So here are my um, vertices connected to make my quadrilateral. What I got to do is I got to see if at least one pair is parallel. So just by looking at it, it seems like the only one that could be parallel is A, B, and C, D. Uh, it doesn't seem like it doesn't seem like any one of those A, D, and B, C would be parallel. We can certainly check that just to make sure. But what we're going to do first is I'm going to look at the slope of A, B, and C, D. So I'm just going to use the slope formula, the y2 minus y1 over x2 minus x1. And so between A and B, I get what, 3 minus 4 over 10 minus 14, which gives me 3 minus 4, negative 1 over 10 minus 14 gives me negative 4, and I get 1/4 as my slope for there. And then CD, I have 2 minus 0 over 20 minus 12. So 2 minus 0 is 2, 20 minus 12 is 8, and 2 over 8 gets reduced to 1/4. So since I have the one set of parallel lines, I can say that yes, trapezoid. Okay, so all right, now again, looking at this next one here, what I'm going to do is I'm going to, let's erase these items. You probably need another um, graph paper or something to write it down. So now I have 1, 2, 4, 1, and finally 3, -2, and 0, -1. So I got, and then all of these will just be 1 unit. So 1, 2, that's A, 4, 1, 1, 2, 3, 4, 1, that's B, and then I got 1, 2, 3, -2, that's C, and I got 0, -1, that's D. So, all right, so kind of looks like they all have the potential to be uh, parallel. So if I have two sets of parallel lines, that's not the characteristic of a trapezoid. So, but we got to prove that by, again, using that slope formula, or we could count them. Let's count them this time. So looking at, let's say, between uh, A and D, so it looks like it goes up 1, 2, 3, into the right one. So this one has a 3/1. Over here, this is going to be 1, 2, 3, -1, so that's -3. This one's going to be -1, -2, -3, -1, so that's 3/1. And then this is going to be -1, -2, -3, up 1, so that's -3. So I have two sets of parallel lines. So this line is parallel to that line, and this line is parallel to this line. Because I have two sets of parallel lines, it is not a trapezoid. As of right now, because it's two sets of parallel lines, I know it's at least a parallelogram. You know, could it be a rhombus, or could it be a square or a rectangle? We'd have to do some other things, but all they're asking for is if it's a trapezoid or not. Looking at these examples here, they want us to find the value of x, so we got to use that mid-segment theorem on the first page. So all we're going to do is take half of, looks like we got the two bases, which is 19 plus 31. So 19 plus 31 gives us 50. So I got 1/2 of 50. So x is going to be 25. In this shape here, we're given one base value, we're given one mid-segment, and then we're given a value for x. So we're going to use that mid-segment theorem, but we have the mid-segment, which is 0.05. We're going to set that equal to the formula, which is 1/2 times it by the sum of the two bases, which is x plus 0.6. So in this situation, we're going to have to distribute. So 0.5 is going to equal, and I'm going to make the 1/2 into a 0.5 as well, just to keep everything consistent, all of them to be decimals. And then plus 0.5 times it by 0.6 gives me 0.3. Subtract 0.3 to both sides. 0.5 minus 0.3 is 0.2. And that's going to set equal to 0.5x. Divide everything by 0.5. I get x is going to equal to 0.4. So that's where that comes from. All right, so they're telling you here that our STV is a kite. So it has all the characteristics that a kite has. Like here, it has consecutive congruent sides. Um, and then it also has some angle measurements. They want us to find the value, the measure of angle V. All right, so if I look here, by rule, the two interior angles that don't share a common or a congruent side are going to be congruent angles. Since we know that S is 75 degrees, I know that V is also going to be 75 degrees. All right, same thing goes here. Uh, we have, looks like these are non-consecutive. This is V. That means that this is also going to be 90 degrees. Okay. And that is being able to use the properties of trapezoids and kites. Hope this helps. Until next time.